everybody. My name is Bataller. I'm an engineer at Witeklab. We're a small company, and I want to thank Maricruz for inviting us to show how long-term monitoring of corrosion in reinforced concrete structures is possible. We are a small technological company which develop technological solutions in the fields of telecommunication, electronics, and integrated computer systems. Our solutions explore the potentials of short, medium, and large-range radio communications. Sorry, thank you. Combined with the advanced sensing and connectivity of mobile devices. In addition to our self-developed products, we provide consulting services and design tailor-made projects to provide advanced technological solutions to companies in various sectors. So, you've seen this diagram quite a lot today. Tutti proposed that service life of reinforced concrete structures can be divided in two main periods, the initiation stage and the propagation stage. Many interpretations of this diagram have been made since it was published about 40 years ago. In general words, the first block corresponds to the ingress of aggressive agents in the concrete cover before the river, mainly CO2 and chlorides, resulting in a progressive disruption of the passive layer on the steel surface. The propagation stage is the active state of corrosion until the degree of corrosion reaches the damage limit tolerated by building standards. With concrete being the second most used material in the world after water, the sustainable business culture in the construction industry is reflected in the life cycle design for new infrastructure and lifetime extension of existing structures. For aging structures, which comprise most of our existing assets, customized maintenance plans should be devised. Actually, deterioration of any component cannot be precisely estimated in advance. Thus, periodic inspection and monitoring programs are advised. Besides revealing the actual asset's condition, this approach aims to reliably project the structure's service life and to help decide if and how effective life extension of the assets can be accomplished through maintenance measurements. Main strategies follow three key actions: prediction, prevention, and correction. Predictive is a maintenance strategy that aims to prevent failures and unimplied downtime. This is done by regularly performing maintenance work before something breaks down. Preventive maintenance is regularly and routinely performed on assets to reduce the chances of unplanned infrastructure closure. Effective preventive maintenance is planned and scheduled based on real-time data insights. Structural health monitoring is the process of using damage detection and characterization techniques for any kind of structure. It is a non-destructive structural evaluation method that employs several types of sensors embedded or attached to the structure. The SHM process includes installing sensors, data acquisition, data transfer, and diagnostics through which the structure's safety, strength, integrity, and performance are monitored. SHM market is estimated to reach $4 billion by 2027, registering growth of 14.6% in terms of value between 2022 and 2027. The rising growth of this market is driven by the importance of monitoring structural health, because the failure of infrastructure can not only incur in very high economic costs, but also result in the loss of lives. Additionally, rigorous regulations related to the sustainability of structures, along with aging infrastructures, are propelling the growth of this market. Regarding the evaluation of parameters of interest in the corrosion-related monitoring, two main strategies can be defined. Those based on manual periodic inspections are usually performed once corrosion is quite obvious. It can be performed exclusively on accessible elements, and the related inspection costs are always high. Some of these manual on-site methods require destructive or semi-destructive methods. On the other hand, remote monitoring is based on continuous non-destructive tests, often by means of embedded sensors. We can obtain data from accessible and inaccessible areas, and it can provide early detection of pathologies. This reduces inspection costs, but you have to plan them in the design phase. This approach is suitable for long-term monitoring, and it can be adapted in already built assets, although sometimes after complex installation processes. To perform long-term monitoring strategies of corrosion, we should focus on techniques which can be automized, such as the ones they have been explained earlier. I like to introduce you a little bit on the technique we at Witeklab are commercially exploiting, which is Corrochip, which give us continuous information on the corrosion rate. This measuring method was patented at UPV and at Valencia a few years ago, and is based on the use of embedded sensors. Those sensors are measured using an electronic device which applies a series of anodic and cathodic voltage pulses. The construction of the elements, and specifically in this demonstrator, we installed the sensor in one of the pillars that were installed inside the water by the dock, and we are now monitoring corrosion-related parameters and enhancing the infrastructure safety. Second example I wanted to show, this is actually a repair of a viaduct that was performed by Acciona, and in this case we have three measuring points with two working electrodes, one counter electrode, and this specific installation we were using photovoltaic power supply, so we are not dependent on the main supplies of electricity, and again uploading the data through a mobile network. This is a very interesting application example because we are installing the sensors on a pre-existing structure, but its performance was being reduced, so they decided to repair it by installing a new reinforcement on the existing beams, and then new concrete. So we are monitoring this reparation procedure. So now we have data of how these new reinforcements will take place over time. As you can see here, the installation process was started before the new concrete was poured, and after that we have to take the cables that come from the sensors, connected to the electronic measuring devices, and just send all these cabling to the corrosion to the gateway that will upload the data to the cloud server for post-processing and then visualization on the web application. As you can see, after the procedure is finished, it's like nothing happened there. So the most attractive thing of this kind of project is that we can access the data from anywhere. This is our website for our Corrochip product. We have geolocalization of the assets we are monitoring. Once we go into one of the installations, we can observe geolocalization, some information, the plans, sketches of what has been done, the number of nodes for sensors we have, which kind of sensors we have here, the number of them. And then we have a visualization, another visualization window where we can visualize all the readings they've been made since it's almost 1 year of monitoring. We can see the evolution of the sensors. So far, no corrosion, no important corrosion processes have taken place. And another option is this is a different option. This is a different example. You can, where 8 sensors were plotted. We can overlap the readings of all of these sensors. And in this specific example, some of the sensors were under significant corrosion processes, and we can see a significant evolution of one of the sensors, which was in quite a passive state and became active after an episode probably of a microcrack or something like that. So the way we are calculating these corrosion currents allow us to calculate the loss of the thickness loss, and this comes from the model that was patented in the UPV, and we can see what Dr. Gandia explained before. We can see how a 2D gradient can be plotted, because after a passive state, the initiation process, then the propagation process continues. And this is another of the relative parameters, so you can combining all the inputs you have from any of the sensors to compare and analyze what's going on. Not only corrosion sensors, specific corrosion sensors allow you to, you can use additional sensors to monitor reinforced concrete structures, and we at Witeklab have the options to install any other commercial sensor you could think of. This is an example of a mobile application where we were monitoring CO2, temperature and humidity accelerometers. So you can navigate through the application and obtain all the readings just in your mobile phone. So for long-term monitorization, it's very comfortable just to take your phone or go into a website from your office and obtain all this data without the traditional ways of doing these things, that you have to take car, travel, and do manual inspection. I don't know if we have time. I think we have. Well, okay. I just wanted to show you. I don't know if it is connected to the internet, probably. So we could just take a look at how easy it is to navigate through data. once you have all the, okay, that's not my computer. So, well, okay, so we have to skip that. So this is all from me. You can read my email here if you have any questions or you need further information on any of our products or capabilities.